Hello and welcome everyone. My name is Aishwarya, and in this recitation, I would like to discuss about the object-oriented concepts for Python. Python is an object-oriented language, but before we delve deep into what and how these concepts are really applied for Python, I would like to discuss more about the term object-oriented and what it really signifies. So, object-oriented is a fancy way to say that we design our codes around objects. These objects are like building blocks that help us organize and manage our code in a better way. In object-oriented programming, software is organized into objects, which are instances of classes. Objects are the building blocks of OOP and are used to model and manipulate data and behavior in a structured manner. They allow you to create instance of a class, each with its own set of attributes and methods. A class, on the other hand, is the recipe for the object that is being created. A class has attributes, which are like pieces of information about the object, and methods, which are like the different things that the object can do. Creating an object using the class's instructions give you a unique object which has its own attributes and methods. Overall, object-oriented programming is a paradigm that really helps you to provide a structure and modular approach to designing and building softwares. It encourages the creation of reusable, maintainable, and understandable code by modeling real world concepts in a natural and intuitive manner. It promotes code reusability through the use of classes and objects, as we discussed. Once you define a class, you can create multiple objects from it, reducing the need to write the same code again and again. This modularity also makes it easier to maintain and update the code. This flexible and efficient paradigm is very crucial for both small and large scale projects. And now we will understand how this is used in case of Python. Now let's understand how we can actually create these classes and objects in case of Python. In Python, classes are created by the keyword class, and a class has different attributes that are the variables that belong to that particular class. As you can see in this example here, we are creating a class using the class keyword that is named book. This line initiates the definition of the class named book, and think of it as a blueprint that describes the properties and behaviors for this certain class named as book. Next, we have the constructor for this particular class. The init method is a special method called or known as constructor, and it's used to initialize the attributes of the objects when they are created. For the class book, we have four attributes: title, quantity, author, and price. The self parameter here refers to the object that is being created. So it is the first parameter for the init constructor, which basically represents the object that is being created at that time. How we can assign these values that are provided by the user to the actual attributes of the class is by using these statements for all these attributes. So what self.title equal to title does is that whatever the value of the title is being given by the user while creating the object will be set for the title attribute of the class by using self.title. And the same thing is being done for other attributes here. For instantiating an object of the class, we can call the class by using the constructor and giving the values for the attributes that were defined in the constructor. For the case of this class, we are using two different objects and we are creating two different objects, book 1 and book 2, each with its own set of parameters. As you can see, for book 1, for example, here we are giving the parameters title, quantity, author, and price. Same is being done for book 2. If we print these objects, as you can see, we are printing the book. It just tells that the variables are objects of the class book, and it also gives the memory locations for these objects respectively. This is a default representation that is provided by Python. If we want to change this representation to make it more intuitive and make it more useful for debugging, Python gives another method known as REPR that is being used here in this another enhanced definition for the class book. Here, this method provides a more detailed and informative representation of the object. So it can be defined in any way that is more understandable for the developer. In this case, we are using the different attributes and mentioning them in this way. So whenever now a print of these made objects will be used. So the REPR method that is being defined here will work with this print statement, and it will return this new representation for the information associated with that particular object. The next thing here is to understand that how we can access the individual attributes of the particular object that is being created. That is done by using the dot operator. Accessing individual attributes of the object using the dot operator is a key aspect of object-oriented programming. For example, here when we print book1 dot author, we are calling the author attribute for the book 1, and it will print the name of the author that is associated with the object book 1. Another example shows how we can call another attribute title for the object book 2. Similar to accessing attributes, we can also access methods that is being created in the class. So for the class book, we created another method here that is getPublish, which is giving the publish date based on the price attribute for for this class. And the only difference between how a method is accessed is that we need to add parentheses in the end of the method name, unlike how we access the attributes for that class. We will now discuss some core concepts that are associated with object-oriented programming in case of Python. The first one is encapsulation. Encapsulation is a core concept of object-oriented programming that focuses on bundling data and methods that operate on the data into a single unit, often referred to as class. One of the key advantages of encapsulation is the ability to control the access to data and protect it from unauthorized manipulation. Encapsulation promotes the idea of data hiding, when certain attributes or methods are kept hidden and inaccessible from outside the class. These attributes are often referred to as private variables. Private variables are not meant to be directly accessed or modified by any code that is outside the class. To create private variable, we use the double underscore in front of the variable name in Python. In this version of class definition for the class book, we have made two private variables, price and discount. As you can see, before both these variables, we have introduced a double underscore, which makes these variables hidden from being accessed outside the class. This is also known as name mangling in Python. So the private variable price is being set to the price attribute that will be given by the user during the time of an object creation. Whereas for discount, we haven't really set a value for this private variable. The rest of the things are similar to what we had previously, the getPublish method and REPR to print the objects. Now, if when we instantiate the book objects using this class definition and we give the values according to the attributes title, quantity, author, and price, it creates the two objects like previously, book 1 and book 2, and printing these books will give more information about the different attributes that the object has as we had previously. But now, if someone will try to access or print the discount variable that we had here, which was not really set, they won't be able to access this particular variable because it's a private variable. If you are trying to print the title variable, as you can see, it is being printed because it's not private, but That won't be the case for the discount variable, and it will throw an error saying that book does not have an attribute discount. Because we are trying to access this variable outside the class definition, we cannot really do that in Python, and that's why we'll get this attribute error here. Similarly for price, which is also a private variable now, even though we set its value using the object definition, we cannot really access it outside the class by using the dot operator. One way to get around this privacy and to actually manipulate these variables is to use setter and getter methods, which is a way to access the private variables in Python. In this modified version of the book class, we have introduced some setters and getters for the private variables price and discount. Firstly, we have a set discount, which is a setter for the discount variable, and it allows you to set the discount value based on the user input. So whatever the user will input here using the discount set discount method and the attribute that will be set for this particular attribute. Next is to define a getter for the price variable. So this method functions as a getter for the private variable price, and it's calculating price based on quantity and discount, returning a price. So this is some random logic that we have just added here, which manipulates the final price based on some other attributes of class. Now, when we instantiate an object from this modified class definition for these two books, book 1 and book 2, we can see that we can actually use the setters and getter methods to access the private variables. So in this example, we are using the set discount or the setter for discount, and we are passing the value 0.15. That will be set for discount, which was initially not set to anything, which was initially none. So using this set discount, now the discount variable will actually be having a value. And similarly for get price, this will be basically returning the price based on how it was defined here. So for book 1, the price that was actually given by the user was 20, and once a user actually wants to see the value, they can use the get price method. Any other definition to getting the price can also be used. So it doesn't really depend on this logic or any particular logic. But yeah, like the final value that we are getting here is based on how it is manipulated here along with the other attributes. Moving on, the next concept that we have in, in object-oriented programming is inheritance. Inheritance involves a class gaining or acquiring characteristics from another class. The class receiving these characteristics is known as the derived class or the child class, while the class giving the characteristics is referred to as the base or the parent class. Inheritance offers a lot of advantages. It effectively mirrors the real world connections between different entities, and it promotes code reusability, reducing the need to repeatedly write identical code. It also enables us to enhance a class with new functionalities without altering its core structure. Now let's understand the concept of inheritance using an example. In this example, we are creating a subclass named novel, which is deriving from the parent class book. How that is done is by passing the name of the parent class within the parentheses while defining the subclass. A class can also derive from more than one classes, but in this case, the new class or the subclass novel is just deriving from the parent class book. This line specifies that the novel class will be inheriting from the book class, and it will also acquire all the attributes and methods of the book class. The constructor initializes the instance variables for the novel class. In this case, we are having 5 attributes for this novel class. By using the super keyword here, we are calling the constructor of the parent class book, and we are setting up the attributes inherited from the book. In this case, the novel class is inheriting four attributes from the parent class book. And in addition, we are also adding one more attribute, pages, along with another method that is specific to the novel class, which is getRating method. When we create an instance of this subclass, it will create a new object which will be having the specific attributes that we defined for this class. The arguments provided match the parameters defined in the init method for the novel class. And after this line of code, the novel book object is fully initialized and can access methods and attributes from both the book as well as the novel class. As we can see, the object novel book is accessing an attribute from the parent class, which is title. Along with that, it is also accessing the variables of the parent class using the setters and getter methods. Subclasses do inherit the private attributes from their parent classes. However, these private attributes maintain their private status within the context of the parent class. This means that the subclass cannot directly access or modify the private attributes, but then again can do that using the setters and getter methods that we defined for the parent class. In addition to that, the novel class can also access its own specific attributes and methods, which is the attribute pages and the method getRating. Another important concept in object-oriented programming is polymorphism, and it is very closely tied to inheritance and method overriding. It enables you to create methods in a parent class that can be overridden in its subclass to provide specialized implementations. This allows objects of different subclasses to use the same method name but exhibit different behavior to their own class. Now let's try to understand the concept of polymorphism with the help of an example. In this example, firstly, let's try to print the novel book object that we created earlier. When we created this object, it also inherited the methods from its parent class. And in the parent class, we did define the REPR method, which which had a particular structure. So the same structure will be used here while we print the novel book or the object of the subclass. But now, if we want, we can override this method and have a specialized implementation of this method in the subclass. So that can be done by defining the REPR method in the subclass novel in a different way. As you can see in this block, we have changed the definition of how we want to display this information in the REPR method. So once we do that, the default representation will be changed to the new representation that is defined here for this method that is being overridden from the parent method, but it has a customized representation in the subclass. Now, after we have defined this new definition for this class and the changed definition for REPR, now if we define another object that is novel book 2 using the novel class, and now if we try to print the novel book 2 object, it will basically give that in the way it has been defined in or the way it has been overridden by the subclass. So as you can see, now this representation matches to the definition that we had here. The name of the method is same to what the name was in the parent class, but because we changed the definition of the function, it is now showcasing that change when we print that object here, which is different from how it was represented before. So this was an example of polymorphism, which showcased how a subclass can change the behavior of an inherited method through method overriding, demonstrating the concept of polymorphism and the ability to tailor methods to meet specific needs. These were some of the important concepts of object-oriented programming that we had for Python. One of the things to keep in mind here is to not really use method overloading in case of Python, unlike it is used for some other programming languages like Java or C++. Method overloading is basically the ability to define multiple methods within the same class, which has the same name for all these methods, but having different parameters. However, Python does not support the traditional method overloading directly, and that is something that I would really suggest to not use when it comes to Python, as you would do in other programming languages. I guess that brings us to the end of this recitation. I hope you learned something about how object-oriented programming works in Python. And I would really encourage you to go through the notebook once again and understand how different concepts work in case of object-oriented programming. Thank you and have a nice day.